Imagine standing on a street corner in a major city during the early 1900s. The scene is absolute and total chaos, a sensory overload that is difficult for the modern mind to fully grasp. You would see a messy, loud, and dangerous tangle of horses, heavy wagons, iron-wheeled streetcars, and the brand new, unpredictable horseless carriages that were just beginning to claim their place in the world. There were no lanes painted on the ground to guide the flow of travel, and absolutely no rules about who possessed the right of way. If a driver wanted to turn left across a sea of oncoming traffic, they simply pointed their vehicle in that direction, gritted their teeth, and hoped for the best outcome. Pedestrians were forced to weave through the gaps in this moving wall of iron and muscle, dodging piles of animal waste and thick mud, while the air was filled with a constant, deafening wall of sound, consisting of shouting men, shrill whistles, and the perpetual clatter of wooden wheels on uneven cobblestones. This was the birth of the modern urban crisis. It was a world that had outgrown its own physical infrastructure with terrifying speed, and for a few years, it looked like our great cities might simply grind to a halt under the weight of their own technological progress. The problem was a fundamental and crippling bottleneck in how we moved from one place to another. For thousands of years of human history, the speed and rhythm of a city was limited by the speed of a walking horse. But suddenly, the arrival of the internal combustion engine changed the fundamental math of the street. Cars were significantly faster and much heavier than anything that had come before, and crucially, they did not have the natural instincts of a horse to avoid a collision. A horse will generally try to avoid walking into a wall or another animal, but a car will go exactly where it is pointed until it hits something. As more people flooded into urban centers looking for work and opportunity, the streets became clouded with a density that the old designs could not handle. It was not just an inconvenience or a source of frustration, it was a public health disaster of the highest order. Thousands of people were being injured or killed in the streets every single year as the machines of progress collided with the people they were meant to serve. The primary solution at the time was to put a weary police officer in the very middle of the intersection to wave their arms and blow a whistle until their lungs ached. But humans are flawed and they get tired. They get distracted by the freezing rain, the blistering heat, or the overwhelming noise of the crowd. They cannot be on every corner at once, and they certainly cannot synchronize their movements with an officer standing 3 blocks away. The hard constraint facing the city was information. Drivers and pedestrians lacked a clear, reliable, and universal signal that told them what to do at any given moment. Without a shared system of communication that everyone understood and respected, every single intersection was a high-stakes negotiation that usually ended in a frustrating stalemate or a violent crash. We had the vehicles, and we had the roads, but we lacked the underlying logic required to make them work together as a single unit. This was the pivotal moment when we realized that building a functional city was about more than just laying bricks and pouring mortar. It required something more sophisticated. It required a nervous system that could send signals from the brain to the limbs of the urban environment. The breakthrough did not happen all at once, but rather through a series of desperate and often clunky experiments conducted by frustrated inventors. In the early 1910s, various creators and city officials began playing with the idea of a mechanical referee that would never grow tired or bored. Some tried using rotating signs that displayed the words "stop" and "move" to whoever was approaching. Others experimented with gaslit lanterns that had to be manually turned by a person standing nearby, which often resulted in dangerous explosions or fires. But the real turning point arrived when we finally harnessed the power of the burgeoning electrical grid that was beginning to thread its way through our buildings. In the summer of 1914, a city in the American Midwest installed what many historians consider the first true electric traffic signal. It was a simple device with 2 distinct colors, red and green, and it was operated by a person sitting in a small booth nearby who could see the traffic flowing from different directions and flip a switch accordingly. This moment changed everything because it introduced the concept of the stoplight as a piece of permanent industrial infrastructure. It was no longer just a man with a whistle, it was a machine with the authority of the law. But for this invention to actually solve the systemic problem of the city, it had to scale up. One light on one single corner was a local curiosity. 10,000 lights operating across a continent was a revolution. This is where the complexities of the supply chain and engineering standards became the real, if unsung, heroes of the story. To make the stoplight work on a massive and reliable scale, we had to solve the difficult problem of consistency. In the early days, every city had its own peculiar ideas about how things should work. Some used white for the signal to go, which caused terrible accidents because a broken red lens would suddenly look like a white go signal to an unsuspecting driver. Others used different sequences of lights or placed them in unpredictable spots on the pole where they were hard to see. The transition from a chaotic collection of local gadgets to a global standard required a massive coordination of manufacturing, engineering, and law. We eventually had to decide on the colors we use today: red for danger, green for safety, and eventually the crucial addition of yellow to manage the dangerous transition between the two. The manufacturing of these signals became a highly specialized industry. Companies had to figure out how to cast heavy iron housings that could survive decades of blizzards, heat waves, and the constant bone-shaking vibrations of heavy trucks passing by. They had to develop specialized lenses that could be seen even in the glare of direct sunlight, and bulbs that would not burn out every few days, which would leave an intersection in darkness. More importantly, they had to develop the timing mechanisms that would provide the logic for the lights. Early signals were often tethered to a central control room where a human still made the decisions. But as the technology spread, we moved toward mechanical timers. These were essentially giant, rugged clocks that triggered the lights in a predictable and unyielding rhythm. This rhythm allowed for the birth of the green wave, a concept where a driver could hit a series of lights perfectly if they maintained a specific, steady speed. This was the first time in human history that we used technology to program the behavior of thousands of people at once, turning a crowd into a synchronized flow. The ripple effects of this engineering feat were profound and permanent. It changed the very shape of our daily lives and how we perceived the world around us. Before the stoplight, the street was a public plaza where children played, neighbors chatted, and vendors sold their wares. After the stoplight, the street became a dedicated, high-speed channel for machines. We invented the concept of jaywalking to keep people out of the way of the now efficient flow of cars, effectively criminalizing a behavior that had been normal for centuries. The winners were the commuters and the logistics companies. Goods could now move across a vast city in a fraction of the time it took before the lights were installed. The losers were the pedestrians, who found themselves confined to narrow strips of sidewalk, waiting patiently for a mechanical light to give them permission to cross their own neighborhoods. This technology also allowed the city to grow vertically into the sky. Without the ability to move thousands of people in and out of a dense downtown core every single hour, the skyscraper would have been a lonely and inaccessible island. The stoplight acted as a valve that regulated the lifeblood of the economy, preventing the heart of the city from clogging. It allowed for the development of the sprawling suburbs, as people could now reliably predict exactly how long it would take to drive into the city for their workday. It turned the act of driving from a chaotic and dangerous adventure into a standardized, predictable, and largely boring process. The economics of the stoplight are equally staggering when you look at the big picture of global trade. Every single minute a heavy truck sits idling at a poorly timed intersection is money lost to the supply chain and fuel wasted into the atmosphere. By optimizing the flow of traffic through engineering, we were effectively adding billions of dollars of productivity to the global economy. They were also saving a fortune in medical costs and insurance premiums by reducing the frequency of horrific accidents. We began to view the city not just as a place to live, but as a complex machine that could be tuned and calibrated for maximum efficiency.
Why does this matter to us today? It matters because we are currently standing at the edge of the next great evolution of this ancient system. The static, timed lights of the 20th century are rapidly being replaced by smart signals, equipped with advanced cameras, sensors, and artificial intelligence. These modern lights can see an ambulance coming from a mile away and clear a path for it before the driver even knows there is an obstruction. They can detect a lone cyclist waiting in the cold rain and change the light faster to get them moving. We are moving from a system of rigid mechanical timers to a system of living, breathing data. The stoplight is becoming the primary sensor for the smart city, collecting vital information on air quality, noise levels, and traffic patterns to help us understand how our urban environments are functioning in real time. Looking back, the invention of the traffic signal was about much more than just safety or mechanical engineering. It was about trust. It was a social contract written in colored glass and electricity. We all agree, as a society, that when the light turns red, we will stop our vehicles, even if there is no one else around for miles. That shared agreement is what allows a city of millions of strangers to function every day without collapsing into violence or total gridlock. It is one of the most successful examples of human cooperation in the history of our species, and it remains hidden in plain sight on every single street corner we pass. The journey from the chaotic mud of the 1900s to the synchronized precision of today shows us that every great advancement in transportation requires a corresponding advancement in management. We cannot have speed without a system to govern it. We cannot have growth without a guide to direct it. The stoplight was the first major step in teaching us how to live alongside the powerful and dangerous machines we had built with our own hands. As we mastered the movement of millions on the ground, the horizon was beginning to shift toward the clouds. The lessons we learned about standards, safety, and mechanical reliability on the street would soon be tested at much higher altitudes and at much higher speeds. In our next episode, we move forward to 1937 to see how the jet engine took these lessons of speed into the sky and changed the stakes of global travel forever. If you enjoyed this look at the hidden engineering of our cities, make sure to subscribe for more